you will be able to write and interpret direct variation equations. Our essential understanding is some quantities are in a relationship where the ratio of corresponding values is constant. So you can write a formula for direct variation as a function, which would be y is equal to k times x, or y divided by x is equal to k, where k does not equal 0, x represents the input values, and y represents the output values. The formula y divided by x equals k says that except for 0, 0, the ratio of all input to output pairs equals the constant k, the constant of variation. So k will be a constant, and we would use the formula k is equal to y over x. And that comes from our direct variation function, which is y is equal to k times x. So we need to use these throughout this entire section. For each function, determine whether y varies directly with x. If so, what is the constant of variation and the function rule? So, in order to determine whether y varies directly with x, we should figure out what k is. So we're going to do y divided by x. So 2 divided by 1 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. Since the constant of variation is the same, k is equal to 2. And our function rule is y is equal to 2x. The next one, we have x and y table. 4 divided by 1 is 4. 8 divided by 2 is 4. 11 divided by 3 is not 4. Therefore, k is not the same, so this does not vary directly. Identifying direct variation from equations. For each function, determine whether y varies directly with x. If so, what is the constant of variation? We need to see if we can rewrite the equations into y equals kx form. I need y by itself, so I divide by 3. I get y is equal to 7/3 x. This is the same format as y is equal to kx, and k is equal to 7/3. Next one, once again, divide by 7. Y is equal to 14x over 7 plus 7 over 7, which is 2x plus 1. Y is equal to 2x plus 1 is not the same format as y is equal to kx, so this does not vary directly. In a direct variation, y over x is the same for all pairs of data where x does not equal 0. We know that because k is equal to k. So, y1 over x1 is equal to y2 over x2 is true for the ordered pairs x1, y1, and x2, y2. Neither x1 nor x2 can be 0, though. So we can use a proportion to solve direct variation. Suppose y varies directly with x and y equals 9 when x equals negative 15. So we know y over x, which means 9 over negative 15. And then we want to figure out what is y when x is 21 is equal to y when x is 21. Cross multiply. We get 189 is equal to negative 15y. Divide by negative 15. Y is equal to negative 12.6. We can also use direct variation to solve a problem. So a salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So these are some steps if we don't want to use proportions, and I think they're easier. We're going to write our equation, we're going to find K, and then we're going to find whatever's missing. So the first thing to do is write our equation. Since we're varying directly, commission varies. When we see varies, put equals K. Directly means multiplication with sales. So that's our basic equation. We're going to find K. So for $1,000 in sales, so K times 1,000 is equal to the commission of $85. Divide by 1,000, and K is equal to 0.085. Now we're going to use this and find the missing information. We want to know what the commission is for $2,300 in sales. So we're going to go back to our original equation, replace K and S so we could find the commission. And multiply 0.085 times 2,300, and the commission would be equal to $195.50. The graph of direct variation function is always a line through the origin. Then the constant K would be our slope. So what is the graph of each direct variation equation? I'm just going to sketch this for us quickly. We have a point at 0, 0, and our slope is up 3 over 4. And the scene for B. To make a table of values, where we have x, y, and we could do 1, 2, 3. So then plug in and we get the values for y, which would be -2, -4, and -6. And we start at 0, 0, then 1, -2, 2, -4, 3, -6. I'm sorry, here direct variation only stays positive, so we're not going to go negative x values. Now you guys try 2 and 3, identify the constant of variation.